weeks, and most students they don't know computer program themes. So it lasts for the teaching of program. It lasts 3 weeks, and in the last week the student need to find any topic they like. So any student can do many how to say such kind of complex pattern things. So okay, it's such kind of things. Okay. So I just okay. So it's about no problem now. Okay. Any problem? Philip Yuan, any problem?
I think the video have some problem, but the acoustic is okay. The sound, we can hear the sound, but cannot see the video.
Okay.
Maybe the files is too big. The last is too big, but this one is fine. I know.
Okay, I don't know. It's a problem of technique. So for the I continue for the higher students. I mean in grade 4 and grade 5, a student can deal with any problem. How to say involved the architectural method. For example, use coding for architectural function, or thinking about the context of environment, and so on. So here's a video. I don't know whether the video can work. No problem?
Yes, this one is okay.
Okay. So it's a course in grade 4. The student coding and use coding find the shape of the pavilion and use KUKA robot to many different kinds of components, and then assemble together. Normally it's for grade 4 for because the student, the architecture students, they like do models, they like assemble, things, they like such kind of pavilion. But on the other hand, they need to learn a little bit more about computer program. The pavilion was how to say was done by students, and after the course, the students know how to control Coca robot and something, and also the computer program. And then a lot of courses in grade 4 is about generative design, which means the student need to use such kind of tool, computer program for finish how to say design, architecture design. We will show any cases here, and so it's about the student. It's a kind of bubble, and use a defined area. Yeah, and the student knows how to deal with the algorithms about pass found and digital star, or the Voronoi, like which means we use a data structure of half ages. It's not so complex. It's very simple, and but the student need to know any algorithms, any data structure, and to get the result achievement. So. Not so complex. And during the student in master and PhD study, they were engaged in one topic. It may be digital fabrication things, or a topic of how to say architecture. For example, here is we finished Taihu Stone. It's near Shanghai and Jiangsu, but use a different way. Use how to say a different method and different material to finish it. Yeah. For master student, normally they do the real project. They must finish the real project. Okay, and also meanwhile they need to finish a kind of research. For example, here is a research for how to say to set the plots, the layout, the texture of a city. Let's imagine it's a block of a city, and then we predefined any plots in the block, and you can define the area for the plots, and then you can set the texture looks like field behind, and then algorithm, the coding can generate the texture like how to say according to field behind. And yeah, this is cases of how to say city texture, and with the blue lines, it's a kind of disturbing element, and then every plot will how to say optimize accordingly. So it's all this is just an exercise for our how to say education course. And Our generative design methods are mainly based on two parts of rules. Aspect of rule-based and data-based, and how to integrate computer algorithm into architecture facts. For example, the architecture function, architecture space, or form, and context, or structure and construction things. Okay, this is a early case. It's finished 5 years ago, and it involved how to transform the functional relationship of building into optimization and process of computer. So let's imagine we can set the relationship of a house on the top left. And then the bubble chart, we call the bubble chart, it defines the relations between a house, and also they share the staircases in location, and define the functions of second floors. And then we set, how to say, a program. And here is the first floor and second floor. They will adapt automatic. And in the bottom, it's the visualize for three dimension. It's okay. It's not so complex. And the top left will show adding parametrics for achievements. It means we extract the problem for architecture function, and then we can define the area of building. We can define the relations between architecture elements, and then computer program can do many such kind of achievements, and every result is different. So all these achievements was generated quickly, but based on the same topology on the top left. So it means you finish the tool, you import the how to define the relations of rooms, and you define the area of rooms, every rooms, and you can get many achievements by programming. I like these cases very much. And here's another case is a project about architecture, space, and function. It analyzes the combining of courtyard in we call Huizhou residential house, such as the feature is about how to say space ratio of courtyard or building space or culture symbols. Because we know in the house, the residential house in Huizhou, they have a very typical style. So we did such kind of tool on the right, and you can define the shape of the plots, and you drag the red line of the plots, and then you will get a suitable layout of courtyard. So on the left, we present many such kind of achievements. It means we also can analysis the residential house in other cities, and then you can do it because we are architects. We know how to analyze the feature of the house. So on the other hand, we can program. We can do how to extract the features, how to make it to digital in a digital way. So it's very free. Okay, and after we finished the tools, you can play around. You can play the result of the program, and you can text the computer computing power of the computer and get the a virtual Huizhou settlement, which means maybe it's you don't need the boundary of you can see the right video. We can get the endless the boundless settlement. So it's just play to how to say to text the powerful of the computer. Okay, here is a case. Is another case is about the form. We also can. It was finished. It's nearly 10 years ago. It was finished by my colleague Hua Hao, Professor Hua Hao, and it can extract the any element of architecture and calculate the feature of floors or walls and so on, and then extract any elements of building, and we can combine this element and get the new result. Let's see what happened. You can define the link on the left, for example, A to B, B and C, C to the third floor of D and E. It's just a simple topo of the space, the link, the staircase, and then you can learn how to form the building. You can see, yeah, it's a you can set the another link, and then you will get a different building. So this case is very funny. And on the left, it's just a user model, user achievement randomly just throw it on the floor. And on the right, we can get different kinds of new achievement based on the many cases we analysis by program, and then extract any features, and the computer can do design for us. Not bad. And another, how to say, we call it the first case we use data-based for generative design. And this project was complete maybe it's 4 years ago as a teaching and researching cooperating with university in Roma. So the principle of the project is very simple. It's just how to say getting the basic data on the OpenStreetMap, and also the functions of the buildings. For example, the POI data, and then search for the building group similar to the design site in the whole city of Roma. And then you can sorting it. The numbers of the, for example, the numbers for flows and the styles and area, and you can sort. We will show the video.
video 没有看到。没有看到。
So
video 还没有。
problem in
好了，来了。
Okay.
有点滞后，稍微。
Okay. It's a pity. So this stake is searching on the whole Roma for the suitable building groups. So this is a key part of our digital tools. So we will get many achievements. How to say, according to predefined sites. It means you can define the shape. You can define the shape of the sites. Okay, this is the case finished by my post students. Okay. Any problem with my computer? Okay. We also need to think about the structure and construction of building. This case was just finished several months ago, and it was done by my master student. The case is how to say. I think it's a series of studies. How to say, armed at finding the type of building structure. How to say, defined by structure. So this is just a case of using or employing finity element researching. How to say, it's a concept, it's a method of in structure. So it's finished just several months ago, and then we can use this tool for finding how to say, finding the shape. I think Professor Philip did many such kind of things, use finity element. But the course was finished by coding. So we can play with the algorithm and try whether it's good or not. And then we also can use. Here is a case of use coding. It's a real project, and employs a computer algorithm for finding shape and optimize structure. It's a case, and one is about structure. Another is about how to make it out. I mean, meaning it's about CNC meaning, and we need to predefined. How to say? It's a little bit complex to explain. The shape of the beam, and we don't want to have how to say, we need a beam, such kind of beam, not just the total things. So so the beam can screw around the surface. So it's a kind of play. It's kind of, how to say, how to make it clear I mean the vectors, which direction of the pavilion of every vectors. So so all components was done in Nanjing and then transformed to Sichuan, Chengdu. So there are many things need to be think about. For example, the size of truck, or the size of CNC machines, and how many, how to say, whether the truck can go through all the nearly half of China, and yeah, many things need to be considered. And is a model of our pavilion, and this is the final result. Yeah, it's this is a photo, and maybe let's see whether the video can work. Huh? I don't know whether the video can show.
No, the video is not coming out, right? No.
Okay, forget it. So one picture is okay.
Okay, it's coming.
Yeah. Huh? I just shut down. Sorry. No problem.
Maybe several minutes slowly than your presentation. It's
okay.
Need time to just.
So, let's move to another database topic. I think many professors in the morning has talking about deep learning or AI. Seems in our group, several students are doing this field, and also Professor Li, he will have a group in this how to say this time, and it's also about deep learning, how to use the principle of deep learning for architecture design. And here is a case, very simple case about deep learning things we did just now. Normally it has several steps for deep learning. I think the deep learning, how to say, the principle and the technique is not so how to say complex. It's because as we know, many how to say models has set by others, and then the key problem is how to translate how to say the architecture element into the LED work. Here is the case we just try to do it. It was finished by my student Zhang Baizhou, and his work several days ago, and just how to say we also get the data from OpenStreetMap. We use PDF file, and then how to say extract all universities campus information, and then clean invalid the data. How to say this is just one word, but a lot of work. How to say to during program, and then obtain several types of the data from multiple angle and extract a data feature. After that is cluster analysis and output visualize result. And then the fifth steps according to the how to say characteristic of integration, and the proposal and for recommendation and match. It's similar as the cases. The case I just introduced for Roma, but it's we search on the we search the data on whole the global yeah. So we try a kind of you know how to say. So the problem is how to define and normalize the existing building site. So as we do for the input, you import data to the network, a neural network. You need to normalize any data. So we just try to use this method for normalizing the shape of the building. Just use a fixed number of point and the angle of each point to the center. The angles, for example, here, how many dots around, and then we just use this kind of method for normalize input data. And then here is any result we searched, and we want to map. We want to map use how to say the searching on the global and find the best fit situation to inform your target design site. So it's a kind of the system can recommend the achievements based on the global data. So here is the cluster diagram. Maybe I have oh, here I open the Any problem with my computer? No problem. So and we use the pixel to pixel taxi to technique to cluster the how to say the school campus like this. And then we use the system for recommending any achievement based on the right the sites. It's similar, and here the result is the campus of university in China. You can see in China campus in the right, always we have X in the compounds, but in the Europe we don't find X. Here we can find X. I don't know. This is Anyang. This is Asia, China. We also have such kind of X. Always have such kind of X. It's very funny. And we also can find how to say, this is on normal campus, And this is a seminar campus in Dani University. And here is a seminar result. And okay, this is my, how to say, I just present any of our achievements. And here's the last short move. We hope it can work. Yeah. So that's all for my lecture. Thank you very much.